Welcome, folks. I think we are live. I'll check if people are joining. Welcome to another episode of the platform community. We have a page in LinkedIn. Maybe you're watching from there, or maybe you are in YouTube, maybe having lunch or breakfast and watching us on YouTube. While you're taking some coffee and then learning about platform engineering, which is the topic that we do in this live stream. As I always, we try to bring the experts from the cloud native community on telling us their stories around what they're building, where they're launching, and then how they're building it, and always with an aspect of open source. So today, I'm glad to welcome the Cisco team from Outshift, Hasith and Sri. So let's go into intros. Hasith, quick intro for yourself. Welcome.
Thank you for having us again, Carlos. Nice to be back. So I'm Hasith, and I lead platform engineering and CISO for Cisco's incubator, which we refer to as Outshift. Yeah, nice to be here and happy to share what we do.
Yeah, and I tag Outshift by Cisco in the linking page, so you can follow that page to stay up to date on all the things that the team is doing. Even their great blog site. I enjoy very the blogs, and then many of the blogs are written by Sri. So welcome, Sri.
Yeah, thank you, Carlos, and thank you for having us. My name is Sri Arajila. I'm a platform engineering architect, lately focused on AI agentic applications, and glad to be talking about this. This is the hottest topic in the platform engineering space in many of the communities out there. So glad to have pioneered some of the stuff we did in this space, and glad to be here to be talking about it.
Yeah, that's the reason we brought Hasith back. We had the first episode. You can watch it in the YouTube or go back in the linking page. But today is part 2. And then part 2 goes into Agentic for platform engineering. So let me show you a little bit here. So Hasith can tell us more about the topic of today.
So main thing is when we look at platform engineering, it is a bottleneck by design in order to streamline the wonderful diversity we have in the cloud native ecosystem. Now, because it's a bottleneck, it does lead into a few issues if it is not working efficiently. So let's look at it from a developer point of view. Often developers get frustrated with both SRE and platform teams, as well as tooling offered. If they don't get a good user experience, and if they don't have, if they're not able to be efficient and effective with their day-to-day job. Now, if you look at on the other side, for platform engineers, this actually end up becoming a significant workload, leading to poor work-life balance, a lot of stress. I've met many individuals who end up burning out doing SRE or being part of platform teams, and this is clearly an issue in the whole industry. So when we kind of looking back, April 2024, we thought, okay, why don't we really take a step with applying AI in order to improve this domain? Because we are a small platform engineering team attached to a very diverse and wonderful accelerator where people are stopping projects very rapidly, pulling in a lot of different directions. So it's really hard to keep up doing platform engineering effectively within such a dynamic team. So that's why we decided to take a step with AI, and especially with the accelerator having an AI focus. So that's why we started this journey, and the results speak for themselves.
So, a little bit of context, right? I think what has been the internal developer platform or platform engineering, right? That I think I work for the cloud, so I see a lot of use cases for the cloud of an organization having developers, right, go directly into the console and start like clicking and then getting their S3 buckets, their VM, and going to another UI and getting a GitHub repo created. So that's kind of like click ups, and you didn't have organization guardrails in there. So that's why they were platform engineering, and then they became ticket ups. So that's why it became a bottleneck. And I think that the solution has been so far, I think until this year, I would say the traditional platform engineering is like, okay, let's use automation. So the input to the users will be a form, right? A form, different forms. We call these templates. They can be in a CLI or can be a web page. So you don't go directly to the AWS cloud provider console, right? You give them a website or CLI where they can select what of a menu, what are the things that they have to do. And then once they go in there, they have to put all the inputs, like how much memory do you need? What is the CPU? What is the S3 bucket that you need? And it's like keep choosing until you hit a button of done, and then you get the things. I think that's like maybe platform engineering V1. I think what we're talking about is, well, it gets to a point that so many forms and permutations that we need to help those people of it's both sides. That doesn't scale very well. So this year, Agentic and the reasoning of unstructured input or unstructured desire from the platform, from the developers, can be automated, right? And could be intake to mean like, what do you mean? And going back and forth. I think this is the angle of Agentic. Like traditional is like, give me a form, I do a template, click, go, automation. This is talking to something different, right?
Correct. So let's say you have a holy grail of platform engineering where you have everything kind of automated towards forms that you can click. But the problem is there's still a big gap getting users to the right form and making sure the information is populated with the right information. And then also, not only that, like providing just information to the users. Even if you have great FAQs, you always, users end up coming to the platform team. Hey, how do I do this? Or I have instances where I have answered the same thing in a chat window. Somebody's asking me the same question in the same context window. So it's like it's in the same history, right? But so that's kind of like, even if with platform engineering, you still have to kind of like be that frontline service team in order to make it work, because you have that gap. Even if you kind of like automate everything towards single forms, right? This is where Agentic can come and really help elevate that to the next level.
Yeah, and I think the prioritization of this is platform team is doing this at scale to the point that you start with one. Let's take, for example, Backstage is a good example, or Port also is you create a capability where people click like the forms that you said, right? And you start with one, and then two, and then three, and then you have 100 of them because you want to have like, what is the specific option you have? So even like finding the form that you're correct, finding the form of like, I solved the issue. I have an IDP with 1,000 templates. Great. Everything is automated. Just choose the right one. Make sure you put the right inputs, right? The right region, the right size. Give me your name, because sometimes he asks you the user ID. Like, I'm logged in. Like, what do you mean? And my GitHub user ID is different from my company ID, but you should figure it out. Like, what's my Jira ticket ID and my GitHub ID and my EKS username or Kubernetes username? Like, why do I need to put all these fields in there? Just figure out who I am. So that's following like, because I think people have hesitant of like, this AI can actually do it and then or not do it, or it can go out well. So if like figuring out this unstructured data is part of it, like understanding what the user mean and also doing it in a safe way. I think that's the safe ways that people are afraid of not trying this out. So let's move on.
Yeah, absolutely. And it's really helpful from that point of view. So coming back to that point, so like the knowledge bases, giving that information when a user asks the question, or guiding the user to the right form, going back and forth with incomplete information. So those type of work is super beneficial if you let AI handle it, because this suddenly elevates the user experience while providing a significant amount of time to platform engineering teams.
Exactly.
Yeah. And
this is an example of impact of like you are using this system at Cisco in the innovation labs where you're located, of like measuring like in production. Like let's say in production, when you run in internal development platform, it's a product, like it's production. People think like it's that outside service, but it's a service for your organization. People rely on their productivity on Sri and Hasith having this system, right, working up and running, right? It's a product. So what's the impact you've seen?
Yeah, so absolutely. So we have been in production for about 10 months, starting small and then scaling up. So we used to have a dedicated support desk that was handling all the incoming requests. We have actually removed that static support desk that we had. So instead, we are able to get our AI engineer as a entry point.
IT requests? You mean when we say requests, is IT tickets?
Pretty much IT tickets, type of tickets. So anybody, so we have venture teams who are involved in different applications, services. So they usually have, I need a new VM, I need a new repository, I need I need access to an EKS cluster, I need my CI setup, I need my CD setup, I need a LLM key.
Like these developers, I need it. They always want stuff, right? They don't give it like ask you to for a coffee, right? Let's go drink a coffee and then let's talk over things. So, okay, I get it. So a lot of IT tickets being done, and a small team, right, cannot handle it in time.
Pretty much, and it's also like I needed it yesterday, and you're already too late, right? You know, it's always rushed, so it's quite demanding. So having AI, an engineer kind of like take that workload really helps us kind of focus on improving what we do for platform engineering, and also elevate the kind of user experience they're getting. So we've been able to do that. Now, response times, when people ask the question, we are human, we don't always pay attention. So it could take hours, right? And you have, different individuals getting frustrated, or different teams, kind of, asking for your time. So responses could, be hours at times, whereas now with
seconds, right? Responses are seconds.
Pretty much. I mean, if it's in the general FAQ or just pointing somebody, hey, we have a form, you need to kind of like go fill in the information here, and kind of like going back and forth, those type of interactions can happen automatically, and that takes a significant toil out of it. Or if it's like a very simple thing, like I just need a development VM, with a certain guardrails, and okay, it's like auto approved, then you can just self-service that completely. Those type of things, it's seconds to minutes basically.
And I see in the middle you have examples of WebEx bot, Backstage, Jira, VS Code, CLI. So the interface to this AI system, to platform engineering, doesn't have to be the typical Backstage, right? The system, the agent is something that is hosted, but access through the VS Code, right? From VS Code, you'll be able to access that AI platform engineer.
Yeah, I mean, here the most important thing is we didn't kind of try to radically change the user experience. It was almost like, what are the interfaces that are being used? And then we kind of introduce it in the most natural way within that user interface. So I know it sounds quite a lot, but developers end up using quite a few things, right? So that's
switching from terminal to VS Code. I do it all the time. I use Amazon Q in the CLI, and then continue to VS Code in VS Code in my IDE, and then continue in the AWS console, right? So I'm using these agents at work, and it knows who I am, right? So it knows the context and all those things. It follows me. Yeah. So and then this is successful at Outshift by Cisco. Is anything, I think last time you mentioned that you were working in the open source community around this project? Like how you're contributing to the community, or maybe taking advantage of the community?
So main thing is so at the incubator we were seeing like a lot of success with this, so it kind of made sense to really elevate this further, because at Cisco we don't have a commercial interest in this space, and when we really look at cloud native and platform engineering, it really is fueled by the community, and there's a lot going on. And then in terms of, I think the biggest challenge with agentic AI is not really the technology; it's actually a lot of social challenges that we have, and also like creating awareness. And so it kind of like felt very natural to really elevate this further and share these kind of benefits with the rest of the ecosystem, and also to kind of like co-develop and further evolve it. So that's why we really elevated it as an open source effort. And the idea here is, in fact, to create a distributed, very much configurable for different enterprise needs or user needs, a multi-agentic system that's going to make it quite complex and an interesting problem to kind of solve to the greater benefit, which is like a pretty cool thing. So glad we are able to kind of like do that, and also yeah.
So in the Canoe project, the CNOE, Cloud Native Operational Excellence, right? It's an open source project in the Cloud Native community. And I recently, a new SIG, a special interest group, got created around agentic platform engineering, right? AI platform engineering, and the vision. And I'm part of that group. So what I understand from the vision of that special interest group, it was maybe two, but one is more important than the other one. So I was compared to the example of, like, let's say that we want to do, there's a company doing a health related AI agent, right? Health related, of like finding the latest research in a certain type of medicine or conditions, right? Just doing research and providing information on what's going on, helping doctors, right, or medical physicians with that. The implementation of it will be JavaScript, Python, LLM models. But if you just get an engineer, software engineer, right, you need a developer to say, we want you to build this health AI system, he can build agents, right? He can look online, like there's LangChain, now there's Strands, there's different AutoGen, there's different frameworks to write Python code or JavaScript, talk to an LLM from a provider, open source. But that developer would not know what is the type of agents or interactions of, like, what are the type of assistants that need to be created to create a multi-agent, what are the scenarios that it needs to be involved, like that aspect. It needs people that are experts in health and science, right? And I think I translate that to platform engineering. We're kind of doing the same, right? We can build agents with all these frameworks and libraries and APIs and containers, but you need like experts to come together of saying, like, well, we need one that, what are the type of agents that we need? One that is dedicated to CI/CD, or one is to DevOps, one for logging, monitoring. What are the use cases? And then, like, how do you put it together to provide that user experience, right? You need that. So I think the Canoe project, that's what it's trying to focus on, like the aspect of, like, what does it mean? What does it good look like in terms of platform engineering in AI?
Yeah, I mean, absolutely. The goal is to really create production grade agents and multi-agentic systems that anybody can kind of assemble and contribute and evolve together. And I think if we come back a little bit, so hopefully everybody is familiar with large language models, LLMs. Now, the reason why agentic has become popular is suddenly when you combine these things, the cumulative impact that you can do is much bigger. So that's why suddenly agentic systems are becoming very popular. And then if you look at the world today, you have kind of like various processors involved. You have data silos. I mean, data silos has existed for the last 30, 40, 50 years, right? They're still there, and you have various processes involved. So when we and if you look at behind any enterprise or platform engineering effort, there's many systems behind the scene. There's many access, there's many data flows, and so personnel involved. So when you really think about all of this, agentic completely makes sense, and multi-agentic makes sense, and then the distributed systems make sense. So that's the kind of what's going to help really accomplished through this effort.
Yeah.
So
So I bet that a lot of people watching us here in LinkedIn and YouTube are like me, like they're scrolling through all these blog posts that talk. Like every day I scroll, maybe that's the things that I like. Like I see agentic AI posts or agentic blog posts, right? Build agents and construct agents, how to secure them, how to run them. But in the Canoe, we're going to work on blog posts of saying like what is we just talk about, like what does a platform engineer is, how can be designed or architected. But I think a lot of like builders or engineers or developers like want to try it out, like reference implementation on like can this scale. And then so let me move to the next section. So this is what the Canoe project have done, right? A repo of having some code that people can try the experiment, or like uh, uh, try it again and then iterate and have a flywheel of like having these agents and then like testing them to see if they actually work, right? Or how to improve them, how to make them secure, how to make it reliable, have the answers accurate. And then a reference implementation comes with this Canoe project of like actually like people trying out with their hands, right? Because this is new technology that people are just getting started.
Yeah, absolutely. So I'm gonna hand it to Sri to go into a deep dive. Now, one last thing I would say here is us adopting and riding this agentic wave and how we incorporate it to platform engineering. We've had to learn a lot of things. We've had to make pivots. We've had to be pragmatic about things. So what we have done is, like, with each step and iteration, we have looked at leveraged our learning, and then we've kind of pushed it further. So that's kind of what's happening with the open source effort. We are really pushing towards more distributed, more configurable, in a way that it's going to really benefit the whole ecosystem. Because if you look at the internal implementation, it's a monolith, and it was done
Really?
done in the constraints of Outshift. Yes, it works really well, but to replicate that success for somebody else, it's harder.
Okay,
so what we are really so that's why with the this pivot, really the open source version is becoming a lot more powerful. And then we are also in the process of leveraging the upstream version and kind of converging there. Happy to get into more details, but I'm going to hand it over to Sri to talk about architecture.
And I want to learn from Sri some of the standards, right? Like this space is changing so fast that new standards get created in 2025. A2A and MCP is like two keywords that I keep scrolling over LinkedIn and seeing like that this is the winner, or that's the winner. And I think Sri explained me the other day, like, well, Carlos, is both are winners. Like one is one for one thing and the other is for other. And in the Canoe, we're not trying to reinvent that, right? We're going to leverage the standards that everybody's using, that they want to implement the health system. They can use the standard and implement health agents. They will use the standards to implement an AI platform engineer.
Absolutely. And as you mentioned, Carlos and Hasith, this space is evolving so fast. There is a lot of complexity in understanding how to build these agents. As you both rightfully said earlier, what we're trying to do in Canoe is to have an opinionated way that we can pick some things that we say that these are a validated design, and we want to make sure that these work. We validated these are reference architectures, not only architectures but actual code implementations that folks could use. And we're also learning these protocols and standards, and some of these standards and protocols are starting to become more generalized. More folks are using them, and they are starting to become more and more popular. So we have taken an approach here where these are a set of opinions we started with, and we always constantly question, okay, is this the right opinion, and where do we tweak, and where can we be more flexible, because we want more flexibility in choice of using someone's tool of choice, but also not too flexible where you cannot have a very much a validated design. So the architecture, with the consultation of that special interest group, and this is an ongoing discussion, and we encourage you to join those community meetings. uh, the architecture we're presenting here is basically, if you think of whether it's a platform engineering agent or a AI healthcare agent or something else, one of the design patterns of building this is called a supervisor agent or hierarchical supervisor agent, where a supervisor agent basically is orchestrating the human language, natural language inputs from a user, typically a user or a chatbot, or you're instructing from a task management system like Jira. You're giving input to this orchestration system, and the orchestration system is able to reason on that natural language question and say, okay, I need to do something, I need to act. So there was this famous paper written by researchers from Google called React. So all agentic interactions are doing a React loop. So they reason on the question, they act and call a tool, and they can go back and forth in many iterations. So in a multi-agentic system like this, where there is an orchestrator, the design pattern we've chosen is, we want to build a sum of parts like Lego building blocks. So we think of some of these platform engineering tools, like people are doing pager duty for their on-call schedules. They are interacting with Git repositories. They're talking to Argo CD for their CI/CD deployments, so on and so forth. So the opinion we have taken is, yes, at Outshift and Cisco, we would choose, let's say, n number of tools to build this platform engineering agent, and we want to make it flexible so that folks can build these sum of parts like PagerDuty, GitHub, and then compose them into this orchestrator, and have this really powerful Uber agent that can do like a Swiss Army knife of, hey, I can get information from PagerDuty, correlate that with Jira, and basically be able to munge all of that information and present it. And as Hasith mentioned earlier, not only this is an information gathering tool in real time, we can also do a lot of self-service tasks. And ultimately, the goal is to be able to really reduce the toil, reduce the barrier of where the information is, and connecting the dots so that we can, you know, for many of the platform engineers, focus on the higher order work, and a lot of that information can be provided by these agents, and a lot of the self-service tasks can be automated with natural language.
So it's really what I'm trying to hear is, because I've seen that's why I said, like, I've seen a lot of A2A and then MCP. Should I use one or the other? And I think what I understanding from you now is that you could have one agent that is connected to an LLM, or one agent which is agentic, has reasoning, and then connected to a lot of tools like direct with MCP. I'm trying like one agent and then a lot of MCP servers, like 20 MCP servers, one for GitHub, Jira, PagerDuty. But I think what you're saying is, if I connect one agent with all these MCP tools, it's an architecture that at scale can have problems, because the model is like too much context from all these MCP tools to be like an Uber agent, and it gets confused of like, what is the right tool to do what. So you're saying like this architecture is a little bit different, where you have a supervised agent that understand the first pass of that on that request, and then try to filter with a small amount of context of like, what do you really need, and then distill that back to another agent or two agents that would perform the task, or like delegates two tasks that then get combined to another agent. And that agent only has MCP tools related to what its role or area expertise is. And that can scale in terms of context, because I think LLM models have it's the context you have to something that is for one is like for it to work, it needs to keep it small. And then the second one, if you are paying for LLMs, they cost money. So there's also strategies of like maximizing the optimizing that usage of that context. Is that correct? That's why we have multi-agent system to solve that issue?
Absolutely, absolutely. I think that that's one of the big reasons why you want to have these agents that have limited set of tools. They are talking to a domain specific. You can treat them as domain specific agents.
I see, domain.
They are talking about a certain domain. They also can be piggybacked on RBAC, so you can use RBAC mechanisms to restrict which set of tools are exposed to the users. And for folks who are not familiar with MCP, and we'll maybe do a little bit of intro. So what MCP really in a nutshell provides is context to the LLMs, right? It's providing tools, as in like if you have an API or an open API spec, it's really exposing those APIs as tools, along with what type of input does the API take, what type of documentation does that API have. So that information is fed back into the LLM as instructions to the LLM to say, hey, if you get a question about this, or if the user is asking to do this, call this specific tool. And that's where the MCP layer comes in. And as Carlos, you mentioned,
I see.
as the number of tools grow, your LLM is having to deal with thousands of these inputs. And that really research has shown, white papers are written about this. The larger the context window, the reasoning really suffers, right? There is a lot of
That's the
conflicting
confusion
information.
that I was referring to. So the technical aspect, Sri is the data science in the team. So it's accurate referring to papers already. I'm just
Yeah.
a cloud DevOps person, solutions architect. And I
Yeah.
think also gives you flexibility, maybe that maybe some agents, maybe the some agents are using certain LL. If you want one agent, you will use one LLM. But if you have multiple agents, maybe you can optimize for like this agent is using a local model, right? Running in the
Absolutely.
same cluster. This other agent is running the agent from this provider. Or maybe this agent is using an LLM that is better on this task than the other one. So not all LLMs are created equal. I think I heard,
Yeah.
right?
And especially enterprise scenarios where maybe there are certain agents that you don't want the data to go outside the boundary of your enterprise. You can use a lot of locally hosted models, and maybe in some cases you're optimizing cost and you want to deploy your own model where there is a lot of high churn in LLM requests, and you're deploying a local model that you then there is enough flexibility of that segmentation. Let's
Okay.
quickly touch on A2A. So the agent to agent protocol, and there are several flavors of these that have come. One from agency, there are the Google A2A, there is ACP from IBM, there are a few other flavors of this. What these protocols really are providing is, once you have an agent, really you can define an agent as a composition of your tools that come from MCP, and you have memory for agent, and you have your system prompt that really explains you, it's giving instructions to LLM what you should do. And also like an evaluation of that agent saying, hey, we have benchmarked this agent to be this level of accuracy for this model, right? You're really, and you're tweaking that agent to making sure that it is performant on these given system prompts, or a set of prompts that you care about. That's what is the composition. And once you compose these agents and you've validated them, these are Lego building blocks. And these agents, like the ones we build in Canoe, they can be hosted like any cloud native service, like a microservice. And these agent to agent protocols help you basically talk to agents like microservices. They provide that communication mechanism like microservices do.
Yeah, I think that the A2A has different protocols. Even gRPC is the default one that you can, one agent can tell another agent like, buy me a car, and it will take a whole day, right? So there's like aspects of like tasks and resuming tasks and notifications back to a webhook of saying this is the progress, right? Notifications like,
Right.
I've been checking dealers today, right? I'm just because I need to buy a car for my daughter going for college. That's what I'm
Yeah.
thinking about that. I don't find my best car. At the end of the day, maybe the agent goes back, right, with notifications, give me that aspect of like that async from agent to agent versus something from an NCP that is a quick API call, right? That is a streaming HTTP typically if it's a remote MCP. But an agent to agent is like, there's reasoning on both sides, like the one asking for things and then the other side like actually reasoning about and then leveraging MCP for that quick interaction of like a tool aspect. So
Absolutely.
let's dig into, because I'm excited because I'm trying to share a lot this GitHub repo to my organization, also in LinkedIn and different places, so people to check it out. Because I want to tell them that on Thursdays we usually have the hands-on workshop in the SIG meeting, but they can, something that we've been working lately on, like getting something quick and easy that people can just try.
Absolutely. So yeah, that's the Git repo here, and I'll show a little bit of a preview when I share my screen here. So if you go to github.com canoe-io, you'll see AI platform engineering. So this is how we are externally referencing this project. Is we want AI platform engineering as like our, hey, you have different personas within this AI platform engineering. You could create your own platform engineer persona. You can have we'll have an opinionated set of incident engineer, Kubernetes engineer that could create you know, manifests, or you can do incident management, those type of things. The landing page is there. Let me go ahead and share
So
my
this is
screen.
just for
Yeah.
reference. Like people may
Mhm.
see this list of like five agents, but the idea is this is a baseline reference implementation. Creating more copies of agents is easy. It's the difficult part, not the difficult part, but the aspect that you can bring in is the speciality, right? You're writing that prompt for that system prompt, and then what are the MCP tools that you're going to orchestrate. But this is just an example of four a few agents that are in the repo. Some of them may grow by the community contributions, right? More
Absolutely.
examples. Like I'm trying to say, this is examples. Like this is not a finite list.
Absolutely. This is not a finite list. And as you mentioned, we will get to the point where composing these agents will become very, uh, even in some cases, we'll get into a point where it'll be automatic in
Maybe
the
there's a
future
registry in
roadmap.
the future, right? Or soon,
Exactly.
MCP registry, and there's also one in the spec, and maybe an agent registry that we can just
Absolutely.
reuse them from a registry, like we used to do with PyPy or npm or maybe all these things.
And we will have a validated set of system prompts that we would have evaluated, and we'll give the user flexibility to override them. Say,
Yeah,
hey, my use case does not use pagerduty, I may be using ops chaining. So you will have that flexibility. If you're using, let's say, an incident engineer persona multi-agent, you could override them and customize them. What we're providing is a set of opinions with a very validated, organized framework that we think can scale with multiple agents.
great, excellent. Let me see. Can you share your screen?
Yep, let me go ahead and share my screen. What we'll do here is do a couple of um, demos of what we built in the open source community. While I set that up, Carlos, Hasith, if you want to look at any live questions, we can answer them. Then
I think there's a few comments that people were saying
Yeah.
this is awesome work. I think I saw also Alessandro from the CNCF ambassador. He said that this is like we're in the gold rush of AI agents, cracking the code to make them really useful and sustainable. Feels like Kubernetes in 2017. Yeah, maybe in 10 years you will see me like it's 10 years from the AI agent project. Remember 1.0, like I do today for Kubernetes. Right.
I'm gonna combine two questions. So one is, yes, the there was a question around the space is very agile. There's a lot of churn. So yes, that is very true. It's very rapidly changing. With this effort, what we are trying to do is make sure that we stay ahead and be competitive. And we are kind of like we are leveraging all the learning we've had internally at Outshift. We are also opening it up to the entire community and being a part of Canoe as well. We really can learn from everybody, implement in multiple systems, and really kind of like similar notion to Kubernetes, right? Keeping things open and really, having the community behind it is going to make it evolve into a competitive play. So that's kind of, how are we going to kind of like navigate that? And yes,
yeah, this is good because some projects well, not to criticize, right? Everybody's trying to, like, the gold rush. A lot of people are trying to build companies, right? That helps you build agents, or like what are the best agents to build, which is okay. That's framework, that's libraries. Cisco brings in something that is being in production. So if you get in touch with someone at Cisco, probably you can ask them, hey, do you know about the IT platform engineer Jarvis? And they probably will say, yes, it's useful. I use it in our company, and it's a real thing. It's in production.
And then this is the other thing. You can also have enterprise agents. So it's like not being excluded in any way. And in fact, there are some enterprise agents coming soon as well, which will be available. The main thing is, it's really having that adaptability and plug and play approach, right? So if you look at, any enterprise use case, you really need various systems and, commercial and open source products, and then all of these things working together in an agentic landscape in order to be really useful. So that's really what we are trying to accomplish.
Yep.
Go ahead.
You're showing the repo here.
Yeah,
It's not what
so
you have here.
I'm showing the repo here. This is the landing page repo. So this is a culmination of several couple of months of work, along with stuff that we have done internally. We've really taken an approach of how do we make it flexible and open so that folks can leverage it. We are at a stable tag right now. So stable, all the agents that we mentioned as Lego building blocks, you can use them in a Docker Compose. So what I wanted to show, and feel free to please take a look at the repo and the README and other artifacts here.
Start the repo. That's something that we talked last week. Getting some stars.
Yeah, that would be amazing. There is a proposal, and I'll talk about that in a minute, to bring all of the efforts that we're doing into this one single repo. So you
Can you zoom in a little bit?
Yeah, I'll zoom in here. So what you're looking at my screen is a Docker Compose, a way, and it's very familiar territory for this audience, platform engineers, a way to launch this AI platform engineer, along with all the associated containers. And all of these agents are containerized, obviously with the benefits that containers bring, with isolation and everything. And the README has all the information on how do you use LLMs, and we have added support for multiple providers, so you can bring your own OpenAI, or Bedrock, Azure OpenAI, or Vertex, whatever your choice of LLM is.
or Llama, or like a small I have a
Absolutely.
Jetson Nano, a Jetson device here that has a GPU, or that people can use reasoning models. But I think the commercial ones are like the ones that you get best results.
Absolutely. So that's what I was going to say is the commercial frontier models have the best reasoning capabilities right now. Your mileage may vary if you're using a local or a smaller model, but this is another effort that's in our roadmap, is to publish evaluation results for various models, various prompts we have been testing, and also very different, the word rubric, meaning what type of measurements are we doing to make sure that there is high accuracy, high determinism, and when you ask a question, it's actually calling the right tool rather than something else.
Yeah, I'm looking
That's
forward for the community to help us write in the folder for features, right? Testing features, put their scenarios in there, like what are their scenarios that they see in the field that takes a long time to try to troubleshoot something or try to optimize something, right? Those features from the community can be put there, and then see how the agent will solve it, and then that's the evaluation, right? How well
yeah,
do you getting the outputs of this not the LLM model, right? Is the agents, and the combination of agent is solving the task. It's not
yeah.
the LLM by itself.
And we can crowdsource some example prompts, because we have seen from our tracing internally that users ask a lot of different
Yeah,
creative
tracing is
questions.
one that I get a lot. Like, how do I instrument my open telemetry tracing app so I can get my trace from one container to another container and then collect it into a Kubernetes open collector, right?
Yeah,
That's something usually developers ask for the first time when they see tracing, but distributed tracing as a DevOps engineer.
absolutely. I think that we will have some of the examples and opinions we'll take in this repo. So we're looking at different tools
So
that are
Docker Compose. So this is if developers are watching this is super simple for you to basically, if you want to write a shell script around these containers in your local computer, you can, or put them in a Helm chart or kubectl apply, create deployments. But we wanted to have something quick, right? That you can show into your organization, say, hey, I saw this open source project, AI platform engineer. Here's a quick demo, demo to my organization internally, saying this is how you compose agents as containers, and they communicate between each other through A2A, and each one will have a set of MCP, right? That's the two sentences. I gave you the demo internally. Like, I do a lot of demos internally, but that's the demo you have to show the organization. And then that's for the engineer part. And the VP is like, this is the value that we get. We get to get things done faster.
Yeah, and as Carlos, you mentioned, this is like the fastest way you can quickly run this and then show proof of value of how these agents actually can help you internally. So one of the other things, and I mentioned about the proposal to combine this, so there'll be more and more activity in this space. We also worked on a tool called most of you may be familiar with Backstage. It's an internal developer portal. So we have open sourced a plugin called Agent Forge, which I will demo here in a minute. Basically, it's a plugin that can be leveraged inside Backstage to communicate with all the agents, like the AI platform engineer. So without further ado, I'm going to open up my a new tab of localhost.
So you already did
Along
Docker Compose up, right?
Yep, along with the Docker Compose app. So this is a Docker Compose. I have ran some examples. Sorry for my screen scroll. I'm just trying to show the front of the run. Basically, this Docker Compose, and if I show the Docker desktop, for example, it's running a set of containers along with the root container and the Backstage agent plugin. And then these containers, the platform engineer is the orchestrator or the supervisor that is talking over A2A to all these other sub agents. And when a question comes in, the supervisor triages and says, okay, I need to understand and reason with this question. And then if there is a need, I'm going to call the sub agent. This is the demo, and it's actually a functioning system I'm going to show. So without further ado, as we mentioned in the slide earlier, that we have let me bring this up just so that you all know. So we have a GitHub agent, we have a Slack agent, Argo CD agent, a Backstage agent, PagerDuty, Atlassian. So I can ask questions that are a combination of these, right? And the supervisor is the one that can orchestrate them, reflect on the questions, and then compose the answers. So the first question I'll ask is something like, hey, show me all the GitHub repos in Canoa.io.org. Um, yeah, so if I ask this question, what just happened is that the platform engineer supervisor got the question. It reasoned that, hey, this question should go to GitHub.
Like a router,
Agent.
right?
Yeah, yeah, and it's routing that
I think
agent.
in A2A there's a they call it router, supervisor. I think I call it orchestrator the other day.
Yeah, absolutely. So if you see what you got here, you got a couple of agent names, and I'll
Can you
say,
zoom on a little bit in the browser?
yep, I will zoom in here. Is this more visible?
Yeah. And this
Yeah,
is the Backstage plugin, which is a very vanilla, very like not a lot of backstage things here, just enough connectivity to the agent that is running in the container, right?
yeah, absolutely. Now that this has actually a threaded view and context of what I asked, I can say, show me more about, let's say, number one, right? I want to know what are the details of number one. So one of the interesting things about this agent is that we compose the agent, but we are using the official GitHub MCP provider, right? So we did not, in some cases where the MCP tooling doesn't exist, we wrote first party MCP server. In this case, we're using the GitHub official MCP server. So what you see here is it went, and all I said is show me more about one, right? It knows what one is from the list, and it knows that it's the context of GitHub, and it went and fetched the description of the repo, how many stars there are, what license it is. I mean, it's pretty amazing, right? If you see the amount of code that's written to build this, it's incredibly
It's,
small, right? We didn't write the
it's
business logic.
text.
Yeah,
The difficult part is writing human text, right? That translate to for the agent into instructions for the agent.
yeah,
So to recap, uh, Backstage has the open source plugin. This is not a Canoe plugin. This is a that shows in Backstage community that anyone can use. So from this web UI, um, talks to the supervisor agent over A2A. Is that correct? And
yep,
then the supervisor says it needs to be routed to the other agent over A2A, and then that A2A, that's A2A agent server part will have MCP, and it's using the GitHub MCP to come back to the answer. So the context and the memory and the memory history of those two things, and when you say give me one, if that was sent to the supervisor, did the supervisor send that to the last agent, or that was not necessary? That's something that I encountered while I was building my agents.
it sometimes the supervisor has enough context, so we can
Or
look
maybe
at the traces.
summarize the instruction
Yeah,
to the second one.
if it has enough info from the context window, it may not send it to the sub agent. It really depends on how the supervisor reasoning and the data it has in its own context window. If you are asking a question from 30 messages ago, maybe that could be you know
The
some of this
supervisor will
interaction.
talk to the user to figure out like what's going on to
Yep.
finally get, oh, I know what you mean. Like I'll route it to the sub agent.
Yeah,
Great.
I will show one more example of a very complex, slightly complex example.
So we did the
But
hello world, right? The people are like not impressed. So let's show them
yeah,
something else.
yeah. So that's, yeah. I mean, this is a public repo. Anybody can find it. No big deal, right?
Yeah.
So this is for all those folks who are incident engineers, or if you are ever on call, you always want to find out who is on call, and hey, find out uh, what task they're working on, right? In this case, internally we use Jira system. So I'm asking a question, hey, show me who's on SRE on call. I'm asking their email address, so we don't show it in this space, and find all the Jiras they have in the last 7 days. It so happens I'm the SRE on call, so I can show my Jiras.
Interesting. Using the agent to help you in the demo. So you mask the. I'm going to use that tip on my next
Yeah,
AI agent
absolutely. And
demo.
you can also say, hey, show me Harry Potter names, right? You could also really ask the LLM to really rewrite your name if you don't want to um, show. So what you're seeing really fast on the left-hand side is it actually went by fairly quickly, and sorry for all the scroll. It went to the platform engineer orchestrator. It then went to PagerDuty to fetch the PagerDuty info. Then, based on the emails from PagerDuty, then it went to Atlassian Jira, correlated, and did a Jira query language JQL, and it's able to fetch that info and get all that data munched together in a markdown format and send it to us, right? That's pretty incredible. It did that within like
So in this
15
case, you use
seconds.
two sub agents.
Yeah, it talks to two sub agents, and this is where the orchestrator comes in, and you'll see some traces of Atlassian here. So it talked to PagerDuty first, got who is on call, and it got the email address of the people, and then it went to Jira agent, and it's able to say, hey, for this user, do a JQL, find all that info, and then send it back to the user who asked the question.
And Hasith, we go back to what we're talking about interfaces, right? This is a prompt where people put something in there, but people can do it from Slack. Like if I'm in Slack, I would just say slash Jarvis, right? Who's on the same question, like, and then the same agent will run in the background, right? The same system will run. Maybe these agents are running in Kubernetes in your corporation. If you are like me, right, we run everything in Kubernetes. And then it comes from Slack, right? Or it could be in the ID, simple ID plugin. But I think Slack will be like it. You can access it from any interface where your convenience.
Many interfaces, and also over time that it could also build a profile about what your preferences are, what are the things you talk about, and kind of like tailor to your needs as well. So I think those type of functionalities will make these systems much more usable and quite powerful in the future.
So before we run out of time, I think the thing that people would say, I think half of the audience would say, this is awesome. And then the other half would say, this doesn't work because then the agents can do whatever they want. What about security?
Yeah, great question. So this is where we're investing in. There are a lot of evolving standards in this space. So we want to use OAuth protocols to obviously authenticate the user from, if you're using Backstage, there is, you use your IDP provider, identity provider, use the JWT tokens, encode the scopes. And there are a couple of ways we can do this. And there are evolving standards in agency collective with agent identity and interleaving human identity with the agents. And also, I think, Carlos, you and we talked about in our forum, how do you do a tool calling on behalf of the user, right? Like how do you,
Yes.
whether you do it on behalf of the user, are you using admin tokens, but are you you're doing scope checks to say, is this user privileged, or doing the right RBAC checks to serve that. So there are evolving standards right now. In this opinion, we have gotten the stuff to work. We have a roadmap to improve, add the right security with Keycloak, add the opinions on how do you deploy to Kubernetes and make it production grade, right? Enterprise production grade.
Yep.
That's what I would say. Yeah.
I would add that in terms of security, these are, I think I try to simplify, but I was going to say treat it as microservices. And the other day, these are microservices talking to each other to accomplish something. So in terms of like microservices, we're talking to each other to establish an order that you buy something online or a transaction in the banking system, right? These are microservices that talk to each other. So the answer solutions architect, it depends, right? But it could be, like you mentioned, it could be like following the best practices that we have done for many years. Don't drop that. Like Sri said, if you are talking to the user, then the user should log in, and that should get an access token on that first stage. And then that access token, then you can decide, I'm going to get another token for machine-to-machine communication, right? So that machine-to-machine communication will not be a user. So that machine may request another token with different scopes and see if you can get elevated access, get a different token, and the machine-to-machine is the authentication, right? Authentication versus authorization. So at that point, maybe you're not the user anymore. You become a parameter, but the user is the other machine. So it's exactly the same as microservices architecture security. And the specs are being updated. The MCP had a problem and it got updated. And A2A also has things like the server giving back in the car saying, these are the requirements for authentication that the client needs to go and figure out how to get it, and then come back. So that communication about requirements of security are in these protocols of A2A and MCP.
100%.
And another way to think about it, so if you look at the implementation and Outshift, you can talk to an agentic system and get your entire CI set up. You could deploy things into production. You could do a lot of things. Now, however, now the way that we have accomplished is when it comes to authorization, you have a very good RBAC. Who's allowed to do what's within the risk boundary. Those type of considerations are being made. Now, with Agentic, I think there are many security angles and a lot of things are coming, and the industry certainly need to mature. But the other beauty of the application of this into a internal, platform engineering type of domain is all of us kind of like get to try it and evolve it in a relatively safe setting to our comforts level. And I mean, in the accelerator, we have been very adventurous and kind of like really push the dial up, but that's kind of the way to think about it in some ways, right? I mean,
yeah, and I think in other episodes we have talked to other guests that they have their DevOps infrastructure all is created through Kubernetes resources, YAML files in namespaces. So use case that you said, if somebody wants to set up a CI/CD or requires a database or an S3 bucket, right? Then the agent can say, can this user with the RBAC that has on the Kubernetes cluster can create an S3.YAML in this namespace called Carlos. If it can, then let me create that S3.YAML, apply it there in that namespace. That's using RBAC, Kubernetes RBAC that you already have established. Like if you do it manually with kubectl or Helm, it's the same as the agent doing it. And then this follows the policies, right? The same way of the S3 bucket we created, because the YAML using things like ACK or Crossplane or curl, like Kubernetes APIs, it's something that you are doing that, then that's the route that you can go with of using Kubernetes for infrastructure, but using Agentic on top of it. So that's something to think about.
I would also add, let's definitely not forget human in the loop and mechanisms to do human in the loop.
Yeah.
Security is one, but in cases where there is, GitOps is not dead, right? We still have mechanisms where we want to see those changes. So we have leveraged a lot of, including these automation along with GitOps.
Review,
and using
approvals, human in the loop.
Through Git using GitHub Actions as backend workflows to trigger agentic workflows. So some of these things are not totally mutually exclusive; they're complementary, right? So you want
to build a system, you're building it faster with Agentic AI. Now instead 100%. Of me going somewhere, I can get a Slack message in DM with a bot asking me, "Do you approve this PR?" And I click on it, and it's faster for me to go to the change code, right, and interact with the bot that is doing. We together we do the review.
Yep.
And with the relevant context, right? So if you look at in most organizations, what has happened to GitOps is people are approving and whatnot, but nobody's really paying attention to like all the changes and the kind of like even following the context, right? So with these type of things, you can actually, okay, 1,000 lines changed. I don't.
Why did they change that? Like, what is it related to? Some change? It's a bug? It's an enhancement?
Exactly.
Who did it? When? Who else reviewed this? Right? You can say, if I'm in the first one reviewing this, right? Those type of things.
So it's like the context, right? I care about the 3-line context, not the 1,000 lines, right? So
I think they can mutually help each other, right? You have GitOps agents helping GitOps, and vice versa. You can kind of bring these things into a harmony and accelerate for sure.
Okay. So with that, I think we're running out of time. This is the call out for everyone to go to this GitHub repo, give it a star, find the Docker Compose, and then configure an LLM, like any LLM that you have an API key. I think that's the instructions, and then it's super simple to set it up. Docker Compose, and then Docker Compose also includes the Backstage, right? So you don't have to worry about like configuring Backstage. It's an example Backstage that you can just give it a try. Sri was very smart to include that. I think it was awesome for the user experience. So watch us on the next episode, and then follows us on the Canoe webpage, follows Hasith and Sri on LinkedIn, and we'll be posting more of this topic. But join us on Thursdays if you want to learn more on hands-on. We put it here on the screen. Here's the QR code. And it's on Thursdays, Pacific time is 9 a.m. And we discussed like what are the new things we should be looking at, like Langfuse, tracing with Phoenix, evaluations, right? So you don't, instead of these logs that you see here, you see a nice trace with colors of what calls what, how long does it take to talk to the LLM, how long does it take the MCP to respond back. Those type of operations when you go into production are important. So until next time, thank you, Hasith. Thank you, Sri, for joining me today. And see you next time, folks. See you. Have a good one.
Thank you.
Bye.